Hi, and I'm going to welcome you to our next chapter, Chapter 13, Lesson 1, which will be on atoms, bonding, and the periodic table. This is from pages 475 through 481 in your Pearson Realize textbook. You will be taking notes, and I hope that this will work for you. The vocabulary list will be valence electrons, electron dot diagram, and chemical bond. First thing I want to ask is, what is a model of the atom? At the center of the atom is a tiny, dense nucleus. A nucleus contains two things. There are positive protons and neutrons with no charge. The third thing that is a model of an atom is on the outside. They are called electrons, and they are negatively charged. They surround the nucleus in the electron cloud. This is an example of a carbon atom. Here you can see that I put in red positive protons, and there are 6 of them. There are also neutrons, and there are 6 of them, and that is the nucleus. Over here, I had to zoom out so that I could show you the electron cloud. The electrons would zoom around so fast that it makes this cloud, and I put 6 negative electrons in there. I put the nucleus and the same 6 red dots and the same 6 black dots. When we look at the particles of the masses for the atoms, the particles in the atoms, you have the protons. They are positive, that's the symbol, the charge, and the atomic mass unit is 1, and I left that in red. The neutrons is an N. Notice there's no symbol, no charge. The mass is also 1, and I put that model in black. The electrons is an E, negative. It's a negative charge. This is such a tiny mass, we don't really count it because it's 1/840th of the size, and I put it in a little orange dot. The atomic number, this is the most important thing, is the number of protons in the atom. So when we count the protons total, that's the atomic number. That's the identification of the atom. What determines an element's chemistry is my next question. Valence electrons are the atoms have electrons of the highest energy. Those are the ones that determines the chemical properties of the element. They're also on the outermost level. When they're buzzing around, they will go on the outside. And to symbolize that, just the outside electrons, we will only show them in what's called an electron dot diagram, which includes the symbol of the element surrounded by dots. For example, here's hydrogen. The symbol for hydrogen is H, and then we put 1 dot because there's 1 electron on the outermost level for hydrogen. Carbon has more electrons than this. However, 4 of the electrons are on the outermost highest level, and that is important. Oxygen has more electrons than this, but on the outermost level there are 6. And it's important again to note that this is the highest energy level. This is where the bonding will take place. Bonding is atoms tend to be more stable with 8 valence electrons. Remember, that's the outermost highest level. And to become stable, the atoms must bond. A chemical bond is the force of attraction that holds atoms together between their valence electrons, and it helps with stability. Now, to understand that, we need to look at specifically the periodic table, how it's set up, because it's set up looking at the groups of the valence electrons and their stability. I put over here, notice that there is an arrow going vertical up and down. That is called a group or a column. Group or columns go up and down. A group within the periodic table of elements have similar properties because they have the same number of valence electrons. Now, going left to right, horizontal, that's called a period or a row. Periods on the periodic table are the number of valence electrons increased from left to right across each period. So that's how you have things similar. Here are some examples of how we look at the periodic table. A noble gas, for instance, that's in group 18, on the far right of the periodic table. They have 8 valence electrons. Helium has 2 valence electrons, and its stability does not react. Metals, the reactivity depends on how easily it loses its valence electron. For example, in group 1, that's the metal group, it's very reactive. Nonmetals become stable when they gain or share electrons. For example, group 17. Metalloids can either lose or gain or share electrons when bonding. Okay, you did it. You made it to the end. And thank you so much for your attention. I appreciate it. If you have any questions, please let me know.